All right, today we're putting on our detective hats for a case that for centuries seemed completely impossible. The mystery? How in the world do you find a planet you can't even see? Let's dive in.
So let's start with a fact that's just wild. There are more planets out there than stars. Just think about that. For every single star you can see in the night sky, there's probably at least one planet, maybe way more. Our galaxy is absolutely packed with them.
Okay, so if they're everywhere, what's the big deal? Why did it take us until 1995 to find the very first one orbiting a star like our Sun? That's the core mystery. What makes these worlds so incredibly good at hiding?
Well, the first problem is the crime scene itself. The sheer mind-boggling scale of space and just the basic laws of physics makes spotting a planet an unbelievable challenge. I mean, the scale of this is it's tough to wrap your head around. A star is about 1 billion times brighter than any planet orbiting it. So, to put that in perspective, imagine standing in San Francisco, okay, and you're trying to spot a single pinhead that's right next to a giant, super bright grapefruit, all the way over in Washington, D.C. Yeah. The planet is just completely swallowed by the glare. Seeing it directly is pretty much impossible with our current tech.
So, how do you solve a case when your suspect is invisible? Well, you look for the clues they leave behind, right? In astronomy, we call this indirect detection. You stop looking for the planet and you start looking for the tiny effects the planet has on its star.
And the very first major clue that astronomers learned how to spot was this tiny rhythmic wobble.
Here's how it works. We think of planets orbiting stars, but really they're both orbiting a shared center of mass. Because the planet has gravity, it actually tugs on its star, making the star wobble just a little bit. And we can see this. As the star wobbles away from us, its light gets stretched out, shifting to the red end of the spectrum. That's a redshift. Then as it wobbles back towards us, the light gets squished, shifting to blue, a blue shift. That repeating pattern of red to blue is the smoking gun. It's the fingerprint of an invisible planet.
And this exact technique is how we got our first huge break in the case. Back in 1995, two astronomers, Michel Mayor and Didier Queloz, were watching the star 51 Pegasi. They saw that telltale wobble and realized it was being caused by a planet whipping around it in just 4 days. It was a massive discovery. The age of hunting for exoplanets had officially begun.
So the wobble method was a total game changer, no question. But our cosmic detectives soon found another technique, one that was even more powerful. It was basically like hunting for shadows, and it just blew the whole field wide open. This is called the transit method, and the idea behind it is actually really simple. If a planet's orbit is lined up just right from our point of view, it'll pass directly in front of its star. When that happens, it blocks a tiny, tiny fraction of the starlight, making the star dim just a little bit. We're talking about a dip in brightness that's almost imperceptible. It really is like trying to spot the shadow of a gnat flying in front of a giant searchlight miles away. So just how effective is this? Oh, it's incredible. NASA's Kepler Space Telescope was built to do just this. It stared at one tiny patch of the sky for years, just watching for those little dips in starlight. And from that one patch, it found over 4,500 potential planets. It proved, once and for all, that planets aren't rare. They are absolutely everywhere.
Okay, so our detectives have found thousands of suspects using wobbles and shadows. Awesome. But finding them is just the first step. Now comes the really cool part, building a profile. What are these worlds actually like?
Exactly. We found a planet. So, now what? What can these indirect clues, these little wobbles and tiny shadows, really tell us about a world that's trillions of miles away? Well, it turns out a whole lot.
And this is where the detective work gets super clever. Remember the Doppler wobble? The size of that wobble tells us the planet's mass, basically how heavy it is. And the transit method? The amount of light it blocks tells us its physical size, how big it is. And if you know a planet's mass and its size, you can calculate its density. And that is the key to figuring out if you found a puffy gas giant like Jupiter or a dense rocky world like Earth.
But wait, there's more. We can actually go even deeper. During a transit, some of the starlight filters through the planet's atmosphere on its way to us. By analyzing that light, we can start to figure out what gases are in its air. We can even measure changes in infrared light to get a rough idea of its temperature. We can build a surprisingly detailed rap sheet on these alien worlds. So astronomers started finding all these planets and building up their catalog of alien worlds. And they pretty much expected to find solar systems that looked, well, a lot like ours. But the universe? It had a huge plot twist waiting for us.
You see, based on the only example we had, our own solar system, our theories were pretty clear. Small, rocky planets like Earth form close to the star. Huge gas giants like Jupiter form way out in the cold. And everyone moves in nice, neat, nearly circular orbits. We figured we'd just find more of the same.
But what we actually found was a total cosmic zoo. We found things called hot Jupiters. Planets bigger than our Jupiter, but orbiting so close to their star that their year lasts just a few days. They were in places they just shouldn't be able to exist. We found planets on these crazy elliptical orbits, swinging way out and then diving in close. The universe, it turns out, is way more chaotic and creative than we ever imagined.
And here's the kicker. These hot Jupiters and other weirdos weren't just rare exceptions. They were common. Their very existence proved our theories about how planets form were, at best, incomplete. It meant we had to come up with whole new ideas, like planets migrating and moving around after they're born, creating all sorts of cosmic chaos.
So this whole investigation has completely rewritten the book on planets and solar systems. And now a whole new generation of detectives is on the case with even better tools. We've got missions like TESS, which is scanning the entire sky to find the closest and best planets to study in more detail. Then you have missions like CHEOPS that are making super precise measurements of planets we already know about. And of course, there's the James Webb Space Telescope, which is so powerful it can study the atmospheres of these worlds in incredible detail and even take actual pictures of some of them, finally pulling these invisible suspects out of the shadows. And all of this brings us to the final, huge question that really drives this entire cosmic detective story. We've gone from knowing about just one solar system to thousands. We know planets are common. That's a fact. But is a system like ours, stable, orderly, with a world like Earth, is that common too? Or are we some kind of cosmic fluke? That's the case file that's still wide open. Are we the exception, or are we the rule?